Okay, now that we've gone over the fact that the angles inside a triangle add to equal 180, we're going to apply that theorem to a few diagrams here and continue with diagrams that we have been working with and show you a different way of answering some of the questions. So, for the purple triangle, if the two given angles are equal to 50 and 72, we add those two numbers together, 50 plus 72, we get 122, and we subtract that from 180, and we get the missing angle is equal to 58 degrees. And you can check your answer by adding those three numbers together to see if it adds to equal 180, which it does. Next triangle, the green triangle, we have perpendicular lines, so that's a 90-degree angle, plus a 48-degree angle, that adds to equal 138, and therefore we subtract that from 180, and in this case we get 42 degrees for the value for x. Now, what can save you a little time, if you have a right triangle, which means you have a right angle in the triangle, if you have one of the acute angles, the other two angles have to add to equal 90. So we didn't have to do this work over here. We could have just stated, because it's a right triangle, that counts for 90 degrees of the 180 for that triangle, so therefore the other two angles have to total the other 90. So I could have found the same answer by just subtracting 48 from 90 and would still get 42 degrees. Two ways of getting the same answer. For the blue triangle, solving for the value for x, we add the first two angles together, 130 plus 30 equals 160. We subtract that from 180 and we get 20. And for the red triangle, now we have to do a little more thinking. We have the total is equal to 180, but we only have one angle given. So we subtract that from 180 and we find the other two angles have to total 140 degrees. But they're both represented by the same variable. So we can state that 2 x's equals the 140 degrees. In other words, we're stating that x plus 40 equals 180. And you solve that equation. Or if this makes more sense, we just divide each side by 2, and we have x is equal to 70. So let's check that answer, because it's a little bit different than the other problems. And we have 70, 70, and 40. So we add those three numbers together, and we get a total of exactly 180. So that checks and has to be correct. Okay, so let's go on to a diagram similar to what we've worked with in the past, but now knowing that we have triangles that add to equal 180, meaning the interior angles of the triangle add to equal 180, we can find the measure of each angle in this diagram a whole lot of different ways. Okay, so let's just zoom in on the diagram. And I'm going to get started right here. I'm going to say that vertical angles are equal. And then I'm going to state that adjacent supplementary angles, or a linear pair, they have to total 180, so we subtract 121 from 180 and we get this angle over here is equal to 59. And just want to erase some of this. Oops. 59. So therefore we have vertical angles are also equal. So we have another 59-degree angle. Now we can move around the diagram quite a few different ways. I could state, for example, let's just get a different color. This angle and this angle are corresponding angles formed by parallel lines indicated by the arrows, the blue arrows over here. So therefore, if one angle is equal to 121, the other angle is equal to 121. Vertical angles there are also equal, so we have another 121. This angle that I just labeled and this angle over on the left, they are corresponding angles formed by parallel lines, the black arrows indicating those two red lines are parallel. So therefore, another pair of corresponding angles will have to be equal. And we have a linear pair right here, so therefore this angle is also equal to the supplement of 121, which is 59, same as before, and vertical angles are equal. And now we can state that, we'll just get yet another color, this angle and this angle are also corresponding angles formed by parallel lines, so therefore they have to be equal in measure. So if the top one's 121, this angle down the bottom left is 121. Its vertical angle is also 121. And we have quite a few of the angles labeled. And we can also state that vertical angles down here in the bottom left are equal, so if this is 25, this angle over here is also 25 because they're a pair of vertical angles. And you can continue quite a few different ways from there. What I want to point out is we can use the theorem that we just went over. See this triangle that I just highlighted in green? Well, the angles inside that triangle have to add to equal 180. So therefore, if we take this 25, this 121, go over to the side and add those together, we get 146. You subtract that from 180 and you get the missing angle inside the triangle has to be 34. Now you can continue quite a few different ways still. You can say that alternate interior angles are equal, and I'll point out the alternate interior angles that I'm looking at. See this Z-shaped figure? The inside corners of the Z have to be equal, so if this angle down here is 25, this angle over here has to be 25 because alternate interior angles are equal. Or we could have stated that these three angles add to equal 180, and a lot of other ways. And we can now state that vertical angles up here are equal, so 25 vertical angles and 34 and 34, that's another pair of vertical angles. And you can check your answer by seeing if the values add to equal 180 degrees, and they do. For example, 121 plus 34 plus 25, they add to equal 10, carry the 1, 8, 180 degrees, so that checks. And same down here, you can find the missing angles here because these angles add to equal 180 because they form a straight line. The angles inside of this triangle have to add to equal 180, or even still, alternate interior angles have to be equal. So a lot of different ways of finding that answer, and vertical angles are equal, so this angle is equal to 34. So starting with just a couple of angles being given, 121 down the bottom right, and this 25-degree angle, and the fact that we have parallel lines and triangles and supplementary angles that were adjacent or a linear pair, we found all of the angles in that diagram. Hope that helps. Good luck.